Section 7.3, it's about trigonometric equations. So what are you going to learn in this section? In this section, three main things here. It's all about solving trigonometric equations. What kind of trigonometric equations we're going to learn how to solve. We're going to look at how to solve single equations or single trig function. So we're going to solve equations with single trig function. So it's either only sine or only cosine or only tan, cosecant, secant, or cotan. Or we're going to learn, we're going to also look at those quadratic, involving quadratic trigonometric functions, trig functions. And the last one, using how we can use fundamental identities to help us solve trigonometric equations. Let me start with an example. If we are asked to solve sine alpha equals 1/2, what they ask us to find? They ask us to find all the alpha values that if I find their sine, I will always get 1/2, 1/2, 1/2. So let's see how we do this. Let's look at the unit circle. Start with the unit circle. What is the first alpha value that would give me its sine 1/2? Well, the first one is 30-degree angles. Right? This is the 30-degree. 30 degree is the first one. The second one is what? When you travel around, that's the 150 degree. I'm going to put it like this, 150. That means that angle is 150. That's the second one. Now, these are the only two values from 0 to 360. And we like people to get used to say more in radians. So this is the same as pi over 6 radians and 5 pi over 6 radians for the 150. And you can convert them. So what happens? So you traveled the first time, you hit this, what we call it, the terminal side. Now, if you continue traveling and hit it again, you're going to get another solution. So if you take the pi over 6, really, if you take the pi over 6 and add 2 pi to it, you get to the same terminal side. And this will give me also 1/2 its sine. Well, the same thing, if I'm traveling around this, and then, you know, the first time you get to this point or this terminal side, if you continue traveling around this, another 2 pi or 360, you're going to hit the same one. So this will be, if I could take 5 pi over 6 plus 2 pi, I'll get this again. Now what happens if I add another 2 pi? So pi over 6 plus 4 pi. Another 2 pi, so it's going to be 6 pi. Same thing, 5 pi over 6 plus 4 pi, 6 pi, 8 pi. What about if someone decides to go backwards? So if I decide, if I'm here, I'm going to go backwards, negative 2 pi. Well, I get the same terminal side. So I can still say pi over 6 minus 2 pi would work. 5 pi over 6 minus 2 pi would work. And I can do minus 4 pi for both of them, minus 6 pi for both of them, and so on and so forth. And now, there's so many solutions. There are infinitely many of them. How can I summarize all of them? Before we do this, notice if this is 30 degrees that I start with, this is also 30 degrees. Do you see from 150? So this is 180 degrees, which is equivalent to pi radians. So always to get the second angle, if you know the first one, the 30, if you know this is alpha, then the other one would be pi minus alpha, or 180 minus alpha. So to generalize all these, to put all these solutions in one or two solutions, we do it this way. I got alpha equals pi over 6 plus 2k pi. And alpha is 5 pi over 6 plus 2k pi. What is k? K is an integer. K is an integer. So integer means it could be 0, 1, 2, etc. or negative 1, negative 2, etc. like that. That's what k is about. So it could be, if you put 0, then you get pi over 6 and 5 pi over 6. Those were the two solutions. If you take 1, k equals 1, you're going to get pi over 6 plus 2 pi, which is this, and 5 pi over 6 plus 2 pi. If you take k equals 2, you get this. If you take k equals 1 and negative 1, you get this. So do you see how it generates all the solutions to this? So then this here, what you see, these are all the solutions to that equation, sine alpha equals 1/2. It gives me, and we say generates all the solutions for that equation. All the solutions means all the alpha values that we need for that equation. In general, what we have, in general, if we have sine alpha, that's how I look at it, equals sine beta. Sine alpha equals sine beta. The solutions to this is always beta plus 2k pi or pi minus beta plus 2k pi. Do you remember the 5 pi over 6 came from pi minus pi over 6? K integer. We always say k is an integer. So that's what it gives us. Now the 2 pi here, you can write 360k. So 360k or 2 pi k. They mean the same thing. They mean the same thing. If, let's say, if we want to solve, let's say the sine alpha is 1/2, provided, you know, under the condition that alpha only from 0 to 2 pi like so, then what we have, remember how we got alpha, we got pi over 6 here and 5 pi over 6, and we said plus 2k pi plus 2k pi. What we take here, we take to find the specific values for that, we take k equals 0. That gives me alpha pi over 6 from the first equation and 5 pi over 6 from the second equation. If you take k equals 1, that will exceed the 2 pi for both of them. That will exceed the 2 pi for both of them. What about if I take alpha k equals -1? Well, that will put them in the negative. So that tells me there's only two values of alpha that would work out this way. Only two values of alpha. No more than two values. What about cosine? In a similar way, so in a similar way, we can work with cosine function. And we're not going to go through an example to prove as I did in the previous example. We're going to just give you the formula if cosine alpha just happened to equal cosine beta. Then in this case, for cosine is going to be beta plus 2k pi, the same as sine, but the other one is negative beta in the fourth quadrant, plus 2k pi. K is an integer, and means any integer. So this is important. Let's try to apply it now to an example. What about if we are asked to solve equation 4 cosine 2 theta plus 3 square root of 3 equals square root of 3. And let's restrict the values from 0 to 2 pi. Well, I want to get this to look like it's cosine something equals cosine some other angle. So it means I need to always solve for the trig function. Here we can subtract 3 root 3 on both sides, so -2 root 3. And then divide both sides by 4, so that gives us negative square root of 3 over 2. Now we need to think about which angle that while I'm traveling in the positive direction on the unit circle, what is the first angle that I come across that its cosine is negative radical 3 over 2. That's cosine 5 pi over 6. That's the first one. It's cosine 5 pi over 6. And now 5 pi over 6, that's the first angle we come across, which is 150. Now what we need to do here is we look at how do we finish this up by using this boxed formula. So alpha equals beta plus 2k pi, or alpha equals negative beta plus 2k pi. So we have 2 theta equals 5 pi over 6 plus 2k pi or 2 theta is negative 5 pi over 6 plus 2k pi. It would be always nice to say k is an integer in every problem we do. Now, can we start taking values for k? No, because I see 2 theta on the left side. So what I'm going to do is I'm going to divide the thetas by 2. So that gives me 5 pi over 12 plus k pi. Divide by 2 here, negative 5 pi over 12 plus k pi. So you must write this as theta equals something or alpha equals something. Now we can start selecting values of k within the neighborhood of 0. So if I take k equals 0, what do I get for theta? 5 pi over 6 or negative 5 pi over 6. But this negative value doesn't work out. Okay, it doesn't work out. What about if I take k equals 1? Then theta would be 5 pi over 12 plus pi, which is multiplied by 12. That's 17 pi over 12. Is that still between 0 to 2 pi? Yes, it is. And then the other one in the second equation, negative 5 pi over 12 plus pi. If I multiply by 12, 12 minus 5, it's 7 pi over 12. So far I have this, I have this, I have this. All of them fall between 0 to 2 pi. Between or from exactly 0 to 2 pi. So they all fall in that interval so far. Now, what about if I take k equals 2? Now notice, if you put 2 here, 2 pi plus that exceeds the 2 pi. But if we put it here, I think it's still fine, because you're taking 2 pi and then subtracting this from it. So multiply by 12. 24 minus 5, it's 19 pi over 12. That's still less than 2 pi. So it works fine. If I take k equals 3, okay, k equals 3, what do we get? The first one definitely is more than 2 pi. But what about the second one? 3. So that would be negative 5 pi over 12 plus 3 pi. Multiply by 12 and 12. 36 minus 5, 31 pi over 24. That's more than 2 pi. That's more than 2 pi. So the only values we get 5, 17, 7, 17, and 19. All of them multiple of pi over 12. So we get 4 values that you see here for that equation. What about tangent? Do we have one for tangent, like tangent alpha equals tangent beta? Yes, there is one, but slightly different. It's only one of them. Alpha equals beta plus k pi, k integer. This generates all the solutions for the tangent function. Let's try to apply it to an example. Solve tangent theta over 2 minus pi over 6 equals 1. Now, I'm not going to put any restrictions here on theta. The question sometimes can be asked by, they can ask us find all the radian angles that would satisfy this equation, for example. This means solve it, solve it. The first thing we do is on the right side, on the left side there's only tangent, but the right side, the smallest angle that you come across on the unit circle, its tangent is 1, is 45 degrees, or equivalently pi over 4 radians. So the formula that we just introduced, it's alpha equals beta. So this one here, this is like alpha, equals beta plus k pi. And again, always nice to say k is an integer. Then we can subtract pi over 6 on both sides. I'd like to combine these two. The first two here, LCD is 12, multiply by 2, by 3. So that gives me theta over 2 equals 2 plus 3, 5 pi over 12 plus k pi. Is it done? No, we need theta. So the next step is to multiply each one by 2 so we can get rid of this theta. You must multiply all of them by 2. So that gives us 5 pi over 6 plus 2k pi. 2k pi. So this is theta is 5 pi over 6 plus 2k pi. This generates all the solutions for us, all the solutions we need. What about if we're asked solve over the interval 0 to 2 pi? That means the same as an angle from exactly 0 to 2 pi. If solve over this, if 2 cosine square alpha plus cosine alpha is 1. So alpha is from 0 to 2 pi. This is quadratic equation. So always what I do, I bring everything to one side, set it equal to 0. So subtract 1 on both sides. Then we need to do factoring here. 2 cosine alpha plus 1 minus 1. So then that works. If you tested negative cosine alpha and 2 cosine alpha, add them up, that gives me the middle one. So that this thing tests fine. So now we can set this equal to 0 or this and this equal to 0. I got two separate equations that I have to solve. Okay, so I'm gonna solve them one at a time. What's the smallest angle? Its cosine is 1/2. In radians, it's the 60 degrees, which is pi over 3 radians. For this one, the smallest angle is cosine -1. That's a pi. So based on the formula, it's going to be pi over 3 plus 2k pi or negative pi over 3 plus 2k pi. K integer. Okay. Here is going to be, notice what's going to give us pi plus 2k pi, or alpha is negative beta or negative pi plus 2k pi. Again, k integer for both systems. And let's finish this up. We need to pick k equals 0. What do we get for the first one? Pi over 3 works. Negative pi over 3 doesn't work. On the one on the right side, pi works, but negative pi doesn't work. What about when k is 1? What do we get for the first one? We get pi over 3 plus 2 pi. That exceeds pi already. The second equation is negative pi over 3 plus 2 pi. Combine them by multiplying by 3, 5 pi over 6. So far we have this, we have this, we have this. In that part on the right side, pi plus 2 pi, that's 3 pi. That exceeds 2 pi. In the second equation, negative pi plus 2 pi, that's a pi, which we already have. Now if we take k equals 2 on, that will exceed the 2 pi. And it can be negative. So there are three values. So alpha is pi over 3, pi, or 5 pi over 6. These are the three values that would satisfy the given equation. Let's look at more examples. What about if we are asked to solve over the interval again 0 to 2 pi, the equation cotan alpha plus 1 times cosecant alpha minus 1/4 equals to 0. So for this one, it's already in a factored form, so they made it easier for us. In order for an equation written as in a factored form, in order for that to be 0, the first one is 0, or the second one is 0. Here, that would give us cotan alpha is -1 if we isolate this, and this is cosecant alpha is 1/4. What is the smallest angle is cotan is -1. That would be the pi minus pi over 4. That's cotan 3 pi over 4. And cotan and tan formula works the same way. So it's alpha equals beta plus k pi. If we take k equals 0 here, we get alpha to be 3 pi over 4. If we take k equals 1, alpha would be 3 pi over 4 plus pi. Combine them, you get 4 plus 3, 7 pi over 4. If you take k equals 2, that would exceed 2 pi. So we have this and this. Here, since we didn't do anything about cosecant, I would rewrite it as cosine by flipping both sides, because that's 1 over cosine, so that becomes 4. But wait, cosine, that's not possible. This is not possible. Why? Since sine and cosine, not just cosine, always the values of sine cosine bounded between -1 and 1. It can't exceed 1. Why is that? Because the graph of cosine always bounces up and down by oscillates between -1 and 1. It can't reach 4. So there are two values of alpha to satisfy the equation, 3 pi over 4 and the 7 pi over 4. These are the only two values. What about another equation, or to solve? Find the general solutions for, let's say, this equation, sine 2 theta equals -1/2. So how do we find the solution for this? We start by asking ourselves, what is the smallest angle its sine is -1/2? So let's see, sine 2 theta. So I always think about it's +1/2. +1/2, that would be 30 degrees. But since it's negative, so it's not going to be in the first quadrant, neither in the second quadrant. So it's going to be here somewhere. So it's going to be the 30 degrees or pi over 6 radians plus the pi. So pi plus pi over 6, that's 7 pi over 6. So it's important to get to that point to figure out what the angle is. So then based on the formulas, 2 theta is 7 pi over 6 plus 2k pi, or 2 theta is pi minus 7 pi over 6 plus 2k pi. Don't forget to write k integer. K integer. So then divide everything by 2. So theta equals 7 pi over 12 plus k pi. And theta equals, oh, this one we need to combine them. If you put this is over 1 multiplied by 6, we get negative pi over 6. But when you divide it by 2, you get negative pi over 12 plus k pi. So this really gives me what I need. K is an integer. This gives all the solutions, what we call them the general solutions. What about another example? Solve for x, the equation 1 equals 2 cosine square x minus sine x if x from 0 to less than 2 pi. So what is going on with this equation? This equation has two different trig functions, sine and cosine. Sine and cosine. So how do we solve this equation? We need to kind of get it to be in one, or rewrite it in one trigonometric function, either only in sine or only in cosine. Well, I can't do anything with that sine, but in the cosine square, I can rewrite it as 1 minus sine square. So now it looks like everything in terms of sine. Let's clean the parentheses by distributing the 2 inside. Then add 2 sine squared to both sides. Add sine x to both sides. Keep the 1, subtract the 2. So that gives me 2 sine square x plus sine x minus 1. So why did I bring everything to one side equal to 0? Because it's a quadratic. So now we try to factor it out. 2 sine x and sine x. It could be plus 1 minus 1. Test it out. 2 minus 1, 1. Yes, that works. So that gives me sine 2 sine x minus 1 is 0, or sine x plus 1 equals 0. So I got two equations to work with, two separate equations. So 2 sine x is 1 by adding 1 to both sides. Divide by 2, and then rewrite the 2 as the 1/2 as sine pi over 6. And for this one here, I subtract 1 on both sides. The smallest angle its sine is -1, is sine 3 pi over 2. And now for each one of them, I can use the formula. Alpha equals beta plus 2k pi, or x equals pi minus beta plus 2k pi, where k is an integer. Same thing here, x equals beta plus 2k pi, or x is pi minus beta plus 2k pi. K is an integer. So what do we do next? Here x equals, keep this the same, plus 2k pi. And this is 5 pi over 6 plus 2k pi. For this one, we get 3 pi over 2 plus 2k pi, or x equals negative pi over 2 plus 2k pi. That's what we have so far. Now we're gonna, because they give me a conditional alpha 0 to 2 pi, take k equals 0, then x equals, from the first equation, pi over 6, second equation, 5 pi over 6, third equation on the right side, 3 pi over 2. And the next one is negative pi over 2, but that negative pi over 2 is in the negative sign, so it's below 0, we can't use it. Now what about if k is 1? If we take k equals 1, what do we get? The first one will exceed 2 pi. The second one will exceed the 2 pi. The next one on the right side up there, 3 pi over 2 plus 2k pi, that will exceed it. But the last one, if I do that, that's not more than 2 pi. If you combine them, you get negative pi plus 4 pi, which is 3 pi over 2. Oh, we already have it, so it matches with this one. If you take k equals 2, it's going to exceed, it will exceed the 2 pi. Negative 1, it will be below 0. So there's only 3 values, pi over 6, 5 pi over 6, and 3 pi over 2. These are the 3 values we have. Now, what about if we look at slightly different kind of equations? Solve, let's say, secant 2 alpha over 3 equals negative 2 over square root of 3 over 0 to 2 pi. There's a secant here, but we didn't give you a formula for secant. So what you can always do is, this is 1 over cosine. Rewrite it. 2 alpha over 3 equals, keep this the same. Then flip both sides. This becomes cosine 2 alpha over 3 equals negative root 3 over 2. And what do we have here? What is the smallest angle? Its cosine is negative root 3 over 2. That should be in the second quadrant. Cosine, well, let me see. Cosine, you forget about the negative sign first. Radical 3 or the square root of 3 over 2. That's cosine 30 degrees. 30 degrees, so that's pi over 6. So 5 pi over 6, 150. Now we use the formula. 2 alpha over 3 equals 5 pi over 6 plus 2k pi, or 2 alpha over 3 is negative 5 pi over 6 plus 2k pi. Don't forget to state k is an integer. K is an integer. Now another thing here, I'm not done with this alpha thing. So what I need to do, multiply everything by 3 because there's a 3 here. Or just multiply everything by 3 halves. So 3 halves times 5 pi over 6. 3 halves times 2k pi. Again, the same thing. Negative 3 halves times 5 pi over 6. 3 halves times 2k pi. K is an integer. So then what we get? Alpha equals by 3 1 by 3 2. 5 pi over 4 plus 3k pi. Alpha equals negative by 3 1 by 3 2. 5 pi over 4 plus 3k pi. Now, did they give me a condition alpha? Yes, it's 0 to 2 pi. So we must start taking values for k. K equals 0. Alpha would be 5 pi over 4 only. The other one, it doesn't work. What about if k equals 1? What do we get? The first one exceeds 2 pi already. But the second one, let's test it out. Negative 5 pi over 4 plus 3 pi. If we combine them as 4, negative 5 pi plus 12 pi, that's 7 pi over 4. Still less than 2 pi. So that's one of them, and that's the other one. And I believe if you take k equals negative or 2 and above, that would not work out. So there's only two solutions for this equation. So you see, just in summary, we tried to solve, just to scroll up, back, we tried to solve equations involving only one trigonometric function, as only a sine or only cosine. We tried to prove to you the general case, which I wrote here. This is the general case, very important for sine. And then I provided you one for cosine. And then this, just an equation involving one trigonometric function, as you can see. And then see tangent, we give you the one for tangent and showed you example. Then after that, we did the quadratic. If we have quadratic type of trigonometric equations, how do we deal with them? So that's trigonometric equations. This is an equation involving more than one trigonometric function, cosecant and cotan, but it's already in a factored form for us. And then it's good to see this kind of example to see that we applied the tangent rule, the same for cotan. And then when we got some cases where it's not possible, just that's something you have to watch for. And then the next one is when I change the angle, it's not just a single angle, it's not just theta. It's not theta, it's like multiple angles, we call it 2 theta or 3 theta. How to work that out. And the next one is it's a quadratic, but also involving more than one trigonometric equation, trigonometric function. So how we rewrite almost all the equations as a one function to make it easier for us. Then do factoring and solve them out. And then the next example was like, what about if it's not just secant alpha or 2 alpha? What about if it's 2 alpha over 3? It's a function or an angle that is a rational, like fractional angle, we call it. And it's not sine or cosine or tan, but secant. So how we work it out? See, I convert that into cosine and I use the rule that we started with this section earlier. And then based on the conditions, we have to run through the k values to see how many theta values we can obtain.